Hello everyone, you're welcome to prevent the solution given this nice algebra problem, which is a to power b subtract b to power a. This is equal to 17. Now, what is the value of a and b? And given that a and b, these are members of positive integers, and given that a is greater than 0 and b is greater than 0. So, solution from here, we have that a to power b subtract b to power a, this is equal to 17. We can express a to power b as a to power b raised to power 1 subtract b to power a raised to power 1. This is equal to 17. The next step here, we can express 1 as half times 2. Now, if you say a half times 2 is the same thing as 1, so let's substitute this. So we have a to power b raised to power half times 2 subtract b to power a raised to power half times 2. This is equal to 17. The next step here, if you have a raised to power n raised to power m, this can be expressed as a to power n multiplied by m. Now the next step here, applying this identity, then it follows that this is the same thing as a to power b over 2 squared subtract b raised to power a over 2 squared. This is equal to 17. The next step here, we just say let a raised to power b over 2 be equal to m, and b to power a divided by 2 equal to n. So substituting this is the same thing as m squared minus n squared. This is equal to 17. And if you recall here, m squared minus n squared, this is in the form of a squared minus b squared, which we can express as a plus b, a minus b. So in this case, we'll have m plus n, then m minus n. This is equal to 17. Now, if you recall, we have that a and b, these are members of positive integers. And given that a is greater than 0 and b is greater than 0, it follows that m is also greater than 0 and n is also greater than 0. And also given that m plus n is greater than m minus n. Okay, so let's proceed from here. Given these conditions, it follows that m plus n, m minus n, this is equal to 17. Now, let's get the factors of 17 here. So the factors of 17, we have 17 times 1, and we have 1 times 17. Now, following this condition that m plus n is greater than m minus n, then we only have 17 times 1. So 1 times 17, this does not qualify, or this does not satisfy the condition here. So now we have that m plus n, this is equal to m minus, multiplied by m minus n, this is equal to 17 times 1. The next step here, we have m plus n, this is equal to 17, and m minus n, this is equal to 1. So these are two systems of linear equations. So let's add these two systems of linear equations, so that here we have m plus m, this is 2m. Now, by adding these two systems of linear equations, we have m plus m, which is 2m, then n plus minus n, this simplifies, and then 17 plus 1, this is 18. So dividing by 2 here, then this means that m is equal to 9. And that implies that n, in this case we have m plus n, this is equal to 17. So we have m equal to 9 plus n, this is equal to 17. So that implies that n is equal to 17 subtract 9, and this is equal to 8. The next step here, we have that, if you recall, we are saying that let a to power b over 2 b equal to m, and that b to power a over 2 be equal to n. So let's substitute this. We have that a to power b over 2, this is equal to 9, which is m. So in this case, let's square both signs here. Let's square both signs here, and that means that this 2 and 2 simplifies so that you have 8 to power b, this is equal to 81. 9 squared, this is 81. So that is 8 to power b. And then we have b to power a over 2. Now let's square this. This is equal to n, which is equal to 8. So squaring both signs here, 2 and 2 here simplifies so that b to power a, this is equal to 8 squared, which is equal to 60. So now we have that 8 to power b, this is equal to 81. And we have that b to power a, this is equal to 64. So we are saying we have 8 to power b, this is equal to 81. And we have that b to power a, this is equal to 64. We can express 81 as 3 to power 4. So we have that a to power b, this is equal to 3 to power 4. And this implies that comparing that the bases here and the powers, we have that a is equal to 3, and we have that b is equal to 4. Okay, this is now for the first case. And we have that b to power a, this is equal to 64. Now we can express 64 as 4 to power 3. So again here we have b to power a, this is equal to 4 to power 3. So comparing the bases here and the powers, we have that a is equal to 3 and b is equal to 4. b is equal to 4. So if we check the first case here, a is equal to 3, and in the second case, a is equal to 3. In the first case, b is equal to 4, and in the second case, b is equal to 4. And that implies that a, comma b, this is equal to 3, 4. Now, these are the values of a and b. So let's verify here. So let's verify. If you recall, we end that a to power b subtract b to power a, this should give us a value of 17. So in this case, substituting the values of a and b, we have a is 3 raised to power b, which is 4, subtract b, which is actually equal to 4 raised to power a, which is 3. This should give us a value of 17. So 3 to power 4, this is equal to 81. Subtract 4 to power 3, which is equal to 64. This should give us a value of 17. In this case, we have 81 subtract 64, and this is equal to 17. And that implies that the left-hand side is equal to the right-hand side. So, and that implies that a and b, which is 3, 4, actually satisfies the equation. So kindly follow the steps, like this video, and subscribe. See you in the next video. Bye-bye.